Welcome. In this video I'm going to show you how you can obtain the effect size measure phi for a goodness of fit test using R and my stikpetR library. I'm using Jupyter Lab with an R kernel. I'm currently having installed a kernel of R version 4.3 and only the basic packages that come with R are pre-installed or ready to go. The code should also work in, for example, RStudio. Now, this is an effect size measure for a goodness of fit test, provided you have a chi-square value. It actually divides this then by the maximum possible chi-square value and takes the square root out of that. It can be converted to Cohen W, and I'm mentioning this because with that you can also then use the rules of thumb for Cohen W. To show you how this can be done, I'll need some example data, so I'll be using the General Social Survey from 2012 data adjusted for some example purposes. I actually don't need all of its data, I just need one nominal field, and I'm going to be using the marital status, which was stored under mar1. So I'm going to call that nominal field, and that's to show you what's in there, a quick table of that nominal field to show you that, for example, 79 people indicated that they were separated. Now my library, stikpetR, is not directly available via CRAN, so you'll need to install DevTools and then install GitHub, and that should give you my library. You can then load it just as any other library, so library stikpetR. For the phi function to actually work, we need three input parameters, chi-square, n, and the sample size, and the minimum expected count. And we only do this after we've done a goodness of fit test. So for example, I'm using here a Pearson goodness of fit test. I have a separate video where I explain how to use this function. But it's fairly simple. It's using that nominal field. Oh, there seems to be a mistake there. So let's copy paste a nominal field. And in the results of that test, it will actually have all you need. The test statistic is the chi-square value. The minimum expected count is in there and the sample size is in there. So we should be able to just run this and we get those three values. Now we can use that phi function. ES is short for effect size. We feed it the chi-square value, the sample size, and the minimum expected count, and we get ourselves a value of 0.40. Now to convert this to Cohen's W, we can use ES convert. Feed it the value, say that it's a phi value, then we want to convert it to Cohen W, and it will need a minimum expected count over the sample size. Once we have that, we can use the rules of thumb from Cohen W, and that will inform us that in this case that can be seen as large. Alright, I hope this video was helpful, and thank you for watching.